Ready? Okay. Welcome back from the short break. Come back from the short break. To look at our last item of the day. That is coming from Jjeb, that is Ginger Joint Examination Board. The number was also set. The Uganda National Road Authority, that is the UNRA, is the upgrading a 50-kilometer road that connects a trading center to a lake community. A Sinotrack transport gravels from a quarry and offloads it at a different point along the road according to the conditions of the road surface. The following offloading records were made along the route. At the trading center, buttons were offloaded. At the swamp area, 40 kilometers from the community, 3.4 tons were offloaded. At the beginning of the hill, 20 kilometers from the center, 2.8 tons were loaded. 30 kilometers from the center, 2.2 tons were offloaded. At the distance of 10 kilometers from the community, 1.6 were offloaded. And then at the lake community, 1.0 were offloaded. The road supervisor wants to plan the distribution of the stone more effectively for the remaining sections of the road. The engineer wanted to offload a stone at a distance of 9 kilometers from the community and also wanted to offload 2.09 tons of the stone. So they are saying the engineer also established the relationship between the quantity of the stones offloaded Y and the distance x in kilometers as the expression was given there as the exponential to power x cos of x plus 1 equals 0 for an interval of x being given as 1 to 2 kilometers for the road design in a particular area. The engineers wanted to perform a dry run to identify the actual location to a degree of accuracy that is 2 decimal point. On the task, they are saying advise the supervisor on the quantity of stones to be offloaded and the location for the offloading from the center. So you realize that in that part one, they want us to get that numbers of tons that will be offloaded after 9 kilometers. And then also they want us to get will be after a graphical approach and the distance where the offload was made. The distance where the offload was made will come as a result of a dry run. A dry run, it is a dry run. It is the sketch of that is a flow chart, or can also come in terms of a design, which will be by the use of either the linear interpolation or the use of the NRM formula. So in Roman 2, they're saying advise the engineer on the most accurate location. That will be still under a dry run. So we'll go back to our Roman part A, which was talking about the advice. So the advice, still you realize that it is coming from a topic of linear interpolation and extrapolation, of which I am going to summarize those information on in the table. In my information, I will look at the distance that will be given in terms of time. They have said the distance it was involving a trading center, and the trading center was being given to the community. So the distance, that is part A, the trading center. trading center to the community. They've said this distance is 50 kilometers. That is as the total distance between them. So I am going to have the distance that will be in kilometers. Then we're going to have the 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 stones. The stone, we can say the stones uploaded in tons. So, and I'm going to read as I summarize. They are saying at a trading center, remember we are moving from a trading center up to the community. Meaning that if it is at a trading center, there is no distance here. The distance here is equal to 0 because that one there will act as our starting point. At a trading center, it was 4 tons of stone being offloaded. And then at the swamp, they are saying the swampy area, which is 40 kilometers from the community. If the swampy area is 40 kilometers from the community, and we know very well that the total distance between the trading center and the community is 50 kilometers, meaning that the swampy area being 40 kilometers from here, its distance from the trading center is only 10. That is if I move from trading center to the swampy community, but to the swamp is 10 kilometers, and then I add the distance from the swamp up to the community to make 50. So this one here means that from the trading center, here we are going to have the 10, that will be added to 40 to make 50. Here they have uploaded 3.4 tons. And then they are saying uh, at the beginning of the hill, 2.2 done. Meaning that even this one here will be 10, which is 2.2. If I add the 0 plus 10 plus 10 plus 10 is the same as the 30 kilometers. And then they also saying at a distance of 10 kilometers from the lake community. A distance of 10 kilometers from the lake community. At a distance of 10 kilometers from the lake community, uh, 1.6 tons was offloaded. So meaning that 10 from the lake community, what is remaining this side will be the 40, resulting into another 10, which is the where they have uploaded to. They have uploaded here 1.6 ton. And then meaning that from there, they have also said that now they are an a distance of 10 kilometers from lake this were uploaded, and at the lake community 1.0 tons were uploaded. Okay? 1.0 tons were uploaded. If you look at now the distance from the trading center up to here, you realize that all of this one here will give us the total distance, which is the 50 kilo 50 kilometers. So we can move on by looking at the number of tons, because they are saying that we should do help the engineer wanted to know at 9 kilometers. At 9 kilometers, we look at the 9 kilometers. The 9 kilometers is going to be between 0 and 9, because if I said it is between somewhere here, this is 20. So we are going to say the amount of stones uploaded at 9 kilo. The amount of stones uploaded at 9 kilometers. That will still be given as the distance, which is in kilometers, and the stone in tons. So is that? So you'll have your 0, that was 4. Then here will be 9, that we don't know. I'm going to use x. Then we go to 10, which is the 3.4. You realize what is inside? This is an interpolation. So we are going to say using linear interpolation. Linear interpolation. Still we are going to have the gradient upright. Gradient upright. What that is y2 minus y1 over x2 minus x1. I'm going to make everything in tons to be y, and then everything in kilometers to be x. So meaning I will have the 3.4, you can say minus 4 divided by 10 minus 0. Because I have subtracted up by 4, even that side I'm going to subtract by 4. The down remains the same. Meaning we are going to have the x minus 4 divided by 9 minus 0. So if I have 0.4 minus 4, 0.4, 3. 3.4. 3.4 minus 4 is around negative 0.6 divided by 10 equals x minus 4 divided by 9. So we can cross multiply. In our cross multiplication, we'll have 10 equals x minus 4 equals negative 0.6 times 9. So we can multiply. This is 10x minus 40 equals to negative 0.6 times 9 is the same as negative 5.4. If I collect like that, this one will go as a plus. So you'll have 10x, which will be negative 5.4 plus negative 5.4 plus 40. So meaning we'll have your 10x being equals to 40 plus 40. This is 3. This is 34.6. Divide by 10. Divide by 10. So x, we divide by 10. This is the 3.4.46. Since what we add here is in tons, meaning that this is the same as 3.46 what? 3.46 tons. Which means I have to conclude. I will say therefore at 9 kilometers, 3.46 tons of stone was uploaded. That is the what was coming in the first statement. And then still as we continue, they are saying and also wanted to upload 2.09 tons of stone. The person wanted to upload 2.09 tons of stone. Uploading 2.09 tons of stone means that at this point we are looking at what distance was the 2.09 tons of stone uploaded. So meaning that I'm going to say distance after uploading 0.09 ton of stone. So we have the distance still in my table, which is the kilometers. Then you have the stone that will be given tons. So at this point, I am going to look at first of all in our turn, because it is the one supposed to guide us. I will compare where 2.09 lies. You realize that for 2.09, it will lie between 2.2 and 1.6. If I start here with 2.2, this will be 2.09, and then we'll have 1.6. Then how are we supposed to allocate the distance? At 2.2, that is at this point, our distance will not be 10, because the 10 we are looking at, it is only from here to here. But I'm going to start counting the distance from here. The distance is this is 0, 10, 20, 30. So meaning this was given at 30 kilometers. And then at 1.6, if this is 30, means that this is 40 kilometers. Meaning we are supposed to find that value of y. That will be also got by using the linear interpolation. Linear interpolation method. So by linear interpolation gradient method, here I'm going to say it is 1.6 minus a 2.2 divided by this is y, then that is x. It will be 40 minus 30. We approximate it to the second values of y, which will be 2.09 minus 2.2 divided by y minus 30. So we can look at that. That is 1.6 minus 2.2. That will still also be negative 0.6 divided by this is 10 equals to 2.09 minus 2.2. That will give us negative 0.11 divided by y minus divided by y minus 30. Cross multiply this goes to that. So you'll have negative 0.6 multiplying y minus 30. Then you'll also have 10 times negative 0.11. 10 times negative 0.11. So we open this. This is negative 0.6 y plus, because we are dealing with negative and a negative. That's why I'm giving a plus. So meaning that we only multiply the 0.6 and the 30, which has given us here 18. And this side will have 10, which is times negative 0.11. That is the negative 1, negative 1 point, that's negative 1.1. Then we collect the like term still, because we are getting the value of y. So you have negative 0.6 y. This one being a positive, you will call that side as a negative. So it's 1.1 minus 18. So you can see minus 18, which is the negative 19 point. That's negative 19.1. You can divide by negative 0.6, divide by negative 0.6. So negative divide by negative 0. This is giving us 31.8. So this 31.8, remember we are looking at the value in kilometers. So this one means that 2.09 tons of stone will be uploaded at a distance of 31.8 kilometers. So in my conclusion, I will say 2.09 tons of stones, 2.09 tons of stones will be uploaded at a distance of 31.8 kilometers. 31.8 kilometers, we can say from the trading center. From the trading center. So that is according to our part A, because they were just telling us to advise the supervisor on the quantity of stones to be uploaded, which is where we done in part 1, and the location of the uploading from the center, where we have done it in this part. And then in the last part, that is the part B. The last part B, they are saying we should help the supervisor establish the road design graphically. This is still an application of locations of routes using a graphical method. We know how a graphical method operates. First of all, we have been given the ranges of the values of x we are supposed to use to come up with the graph. So here we are going to use the value that is from 1 to 2, giving us the function that is the expression that is the exponential of cos x plus 1. Come up our graph. And again, the next thing we should always know is that whenever we are told to draw a graph, when the expression given is having a trigonometric function, we should have our calculators being given into the radians. Because if I don't give it the radians, the values we are going to obtain there will be given as the bigger values. That may not be able to act as the approximate value of the root. So that is what I'm going to use. Make sure your calculators is changed into radians whenever I look at a trig function, that is in terms of cos, tan, and sine, any angle. So in this part, I am going to say let the function, we can say f of x, which was given by y. This one here is the same as the y. Be exponential x cos of x plus 1. But they have given us the x being 1 less or equals to x less or equals to 2. I am going to use that expression there to come up with my graph. I will tabulate my values having x and also having y, where y is the same as the f of x. When we use the ranges of values from 1 to 2, I can say 1, maybe 1.2. If I use an interval 0.2, 1.4, 1.6, 1.8, and you reach 2.0, meaning that even this one should be 1.0. So I am going to get the values of y. First put my calculator in radian. That is 2. So you'll have the exponential, second shift, exponential of 1, then the cos of 1 plus 1. So this is giving me around 2.5. If I round off to 1 dp, go to another one, exponential of 1.2 cos of 1.2, then plus 1. This is 2.2. Go to another one, the exponential of 1.4 cos of 1.4 plus 1 to get 1.68, which is approximately to 1.7. To have exponential 1.6 cos 1.6 plus 1. This is the 0.9. Go to another one, exponential 1.8 cos of 1.8 plus 1. So this is the negative 0.4. Then finally, the exponential of 2, exponential of 2 cos of 2 plus 1. This is negative 2.1. So meaning that is what I'm now going to use to come up with my graph. So you're going to plot a graph of x, of y against x by using this value. What we are going to obtain as the root, that's where the graph cuts the x-axis, will be acting as the initial approximation of the root. So, yeah. This is y. This is the x. I am going to use a scale of 2 centimeters. Okay. I'm going to use on x-axis using 2 centimeters to represent 1 unit. Then on y-axis, I will also use 2 centimeters to represent 1, also represent 1 unit. The reason why we are doing so is to ensure that even the values like 1.2, 0.9 will be plotted successfully. Because if I look at the 2 units, that the 1 unit will represent 2 centimeters, meaning we are accounting for 10 small boxes, whereby each small box may be accounting for 0.1. So I'm going to have 1, 2, I'm going to use 0.0. Then I can also use negative 1.0. So this is 1.0, 2. Down but so we can go ahead and then we plot. The first part is 1.0 against 2.5. So you realize that this one will be around somewhere in the middle there. Go to another one, 1.2. 1.2 is after 1, but a difference of 2 smaller boxes against 2.2. 2.2. So 2.2 also will be down here. Then the next one is 1.4 against 1.7. 1.4 is after 1, but a difference of 4 small boxes. And 1.7 also here, a difference of that. So we can have that. We go to another one, 1.6, which will be somewhere here. Again, is 0.9, which is approximately 1. 1.8, which will be around here, having negative 0.4. Negative 0.4 will now be down here. Then the last one, 2.0, again is negative 0.1, negative 2.1, I mean, which is around somewhere there. So in my graph, this is what I'm having. That so this graph should always be labeled as what the expression was giving us. So in my graph here, uh, from yours, you are going to use the real graph where you by your answer of the x naught may not be equivalent to mine. Because mine, I don't have the appropriate point where I'm going to obtain my values. But basing on the approximation, I am going to approximate my initial that is obtained from the graph as maybe 1 point. I'm going to approximate it to be 1.9 basing on where I'm seeing my graph is cutting the x-axis, meaning that the 1.9, it is what we are going to use to obtain the value of the approximation we were looking at. And in my approximation, I am going to use the method of the NRM, whereby in the NRM, we are supposed to get the NRM formula for given function. So keeping 1.9 as a constant, we are now going to get the distance where this one is uploaded. So you realize that the distance where the stones were uploaded was uploaded at a distance of 1.9 kilo, distance of 1.9 kilometers. We go and look at the last part, that is part Roman 2. Roman 2, which is the last part of the discussion. Yeah, said that we are going to look at the NRM formula, but I wish to first keep my x naught, that was 1.9. The NRM formula, given our function, that was exponential of x plus of x plus a 1. That's what we are looking at. But you know very well that in NRM, we look at the formula being equivalent to that is x, eh? Minus f of x of n divided by summation of that. At this point, we are having f of x, but we don't have the f of the f prime. The f prime means the first derivative of the function, that is f of function f of x. Meaning, also I should come and find the first derivative of the function. But if you look at the function in the first part where we are seeing the exponential of course, you realize that this exponential of course can be differentiated in different parts. The different parts, we mean the part being having a product of the two components, meaning that I am going to apply the product rule. In the product rule, we talk about u and then we talk about v. This is a formula that says that whenever I'm going to differentiate, we're going to deal with u, the v, the x plus v, the u, the x. Meaning, I have to keep u constant and then you differentiate v. Now, at this point, I'm going to keep my u, which is the cos, which is the exponential. Then I differentiate a cos, which will give us a sign, xn. This sign is a negative. A plus. Keep v, which is the sign, differentiate this. If I differentiate, remains the same. Then I will keep this one. And then afterward, we differentiate this, which will be 0. So in a simple way, our function or the first derivative of the function will be negative exponential of sine plus exponential of cos. Then the substitute in the formula. This is xn. So you have the xn minus negative exponential of xn sine of xn plus the exponential of this cos of that divided by the, no, this is wrong. You have to put the function that is x of n cos of xn plus 1. Then we put the function now. That is the negative exponential of xn sine plus the e exponential cos of xn. Can summarize this having xn, that's if I cross multiply, being negative sine xn plus the exponential xn cos xn. Then I am after multiplying this, I'm going to open this bracket with a negative, meaning this will be negative xn cos xn and then minus 1. We divide it by negative exponential xn sine xn plus the exponential xn cos of xn. So I am going to leave this as it is, since the question was not asking for the NRM. I will just use it as the formula for the NRM because there's nowhere I am going to prove this. But don't forget to put the the n equals to 4, and if you have the space, you can put a comma. Then you put for n equals 0, 1, 2, 3. Then we're going to look at a dry run. We're going to look at a dry run. In our dry run, they are saying that the engineer wanted to perform a dry run to identify the actual location to a degree of accuracy of 2 decimal points. The degree of accuracy, in summary, the degree of accuracy that is given to 2 dp. This one, they are trying to tell us that the error we are going to get, that will be obtained from the magnitude of the xn. We can also use xn plus 1. That is having the xn plus 1. This should be less than, when you talk of 2 dp, should be 0.005. That is what we are going to look at. Whenever we find our error, which is less than that, meaning that one there will be given as our approximated root. This one will act as the x naught, and this one here will keep on increasing other values. So I am going to get a dry run using the NRM formula. Our dry run should have the values of n where we are located here before. And then we'll have the values of the x naught. That was the initial approximation. The values of x naught will be followed by values of x n plus 1. Then finally, we will look at the error now. That will be the magnitude of xn minus xn plus 1. Here. The error should be asked in terms of the question, meaning I should say is, because it is the magnitude of xn minus xn n plus 1. Is it less than 0.05? That's according to the try run. So I'm going to be substituting for the first value, that is when our n is 0. When our n is 0, we add the value of the initial approximation, that was 1.9. So given the values of the initial approximation, which is 1.9, we are supposed to go and obtain the value of n, x of n plus 1 by substituting for initial approximation into the formula of the NRM. So I'm going to substitute 1.9. So we'll have the 1.9 negative exponential 1.9 cos of 1.9. Make sure that your calculator is radian. That should be 1.9. Open the bracket, negative exponential of 1.9 cos of 1.9 plus the exponential of 1.9 cos 1.9. Then we cross our bracket minus exponential 1.9 cos 1.9 minus 1. Then you divide by negative exponential 1.9 sine 1.9 plus exponential 1.9 cos 1.9. Close the bracket. Make it to repeat. Have negative negative exponential of 1.9 sine 1.9 plus second shift exponential 1.9 cos 1.9 times 1.9 minus the exponential 1.9 cos 1.9 minus 1 divided by negative exponential 1.9 sine of 1.9 plus exponential 1.9 cos 1.9. So the answer here is 1.158. That is what we have got after substituting for this, meaning we are supposed to find the error, which will be on this by subtracting, because here we are looking at x and being equal to being subtracted from that. This xn is the one which is acting as the initial approximation, meaning I get this minus that value. Subtract 1.9 minus 1.158. This is a 0.742. 0.0742. This one is calling for a no, because when you look at this error, it's not less than 0.05. So at this point, I will have to look for another value of the initial approximation, because as you see the formula n plus 1, I keep on adding the value of n, meaning this one here we are going to go for another value of x, which is the x1. x1, I will use the value which is here. I get the initial to act as the new. So meaning I'm going to transfer the 1.158 this side. Then this 1.158 is acting as the initial approximation, where I'm supposed to go back and substitute that. So can we do? I am going to use now 1.158, which is negative of exponential 1.158 sine of 1.158 plus the exponential 1.158 cos 1.158, then times 1.158 minus the exponential of 1.158 cos of 1.158 minus 1. I divide by negative negative exponential of 1.158 sine of 1.158 plus the exponential 1.158 cos of 1.158, close the bracket. So this is giving me 1.157. So 1.157 is the, if I subtract, to realize that this one will give us 0.01, where 0.01, according to our decision, is the calling for yes. That is our final part. A yes means that the road will be lying in that part. So to work out this, meaning I will not proceed with my calculation because the error we have obtained is less than 0.05. So this will call for a conclusion. This will call for a conclusion after a dry run. Our conclusion will be the most therefore the most appropriate location is the value we have got, which is 1.18 kilo, 1.18 kilometers. That one becomes the last part of our today's discussion. So as you're outside there, you can feel like you should do the same more numbers basing on the same method and the same approach using the same ideas. As of me, I have a lot of numbers. You can share them with you. But for any inquiry, you can also inbox me on the number, which is 0783602 Someone can use this number to submit in any questions where you feel like it has been giving you a lot of headache in my inbox. I will be able to work it out together with you. Thank you. Wish you a nice time.